Alright, so Doreen Schmidt is a chemist with Gemco Pharmaceutical. She needs to prepare 12 ounces of a 9% hydrochloric acid solution. Find the amount of a 4% solution and the amount of a 12% solution she should mix to get this solution. Alright, so I'm trying to determine the amount or the number of ounces of a 4% solution and the amount or the number of ounces of a 12% solution she should mix to get this solution. Okay, so I assigned X to be the amount of the 4% solution and Y to be the amount of the 12% solution. Okay, so those are the two things I'm trying to find. In order to find those, I need to set up my system of equations. So I'm going to derive two equations from this word problem. And the first equation is going to come from the total number of ounces that I can use. Okay? So I can only have 12 ounces. So that means when I mix the 4% solution with the 12% solution, 4% solution being the X, the 12% solution being the Y, I can only get a total of 12 ounces. So if I add the two amounts together, the total should be 12. So there's the first equation. Nothing too bad there. The second equation is going to involve assigning percentages to these amounts that we talked about. Alright, so the X I originally assigned to 4%. So the X is a 4% solution. The Y was assigned to be the 12% solution. And the 12 ounces needed to be a 9% solution from the problem. So 9% times 12. Okay, so here are my two systems of equations. And what I could do here is I could change my percentages into decimals by moving the decimal two places to the left. But I would counteract that by multiplying by 100. So I'm actually just going to leave them in the form they are now. So this would just be 4x plus 12y equals 9 times 12, which is 108. Okay, so I'm going to scratch through that equation, and using the two equations that I have now, I am going to solve this system. The x's, the y's, and the numbers are lined up, so this works better with the addition method. But I could easily use the substitution method. It would work as well. I am going to multiply the top equation by -4 and the bottom equation by +1, which you can probably tell what I'm trying to do is to get the x's to eliminate. So let's distribute -4 times the top equation, and I would get -4x minus 4y equals -48. The bottom equation I'm multiplying by 1. It will not change. It will be 4x plus 12y equals 108. Alright, so I'm going to add these two. Notice my x's cancel, which was my goal. -4x plus 4x eliminates. -4y plus 12y is 8y. And -48 plus 108 is 60. Okay. Dividing both sides by 8, I get y to be 7.5. Okay, so remember y represented the amount of the 12% solution. I know y. I'm going to come back and find x. I'm going to go back to one of my original equations, and I'm actually going to go back to the x plus y equals 12, which looks to be the easiest of the two equations. So I know y to be 7.5, so I will substitute that in. Now I need to subtract 7.5 from both sides. And I will get x to equal 4.5. So it appears that y, which represents the amount of the 12% solution, is 7.5 ounces, and x, which represents the amount of the 4% solution, is 4.5 ounces. And if you'll notice, 7.5 ounces and 4.5 ounces combined are total to be 12 ounces. So that makes a lot of sense in this problem. Hope this helps.